Okay, today's lesson is lesson number 54. This is Systems of Equations word problems. So we're going to be able to solve some word problems using the methods that we've talked about the past few days with solving linear equations. So graphing, substitution, and elimination. The first thing we're going to do for these problems is read the whole word problem and kind of get a visual picture in your head of what's going on in the situation. Then you want to identify what the problem wants you to find. Okay, for these, there should be two things because our systems have two variables, right? So there should be two different things that you're looking for. You're going to assign these two variables different letters. I would use letters that make sense with what it's asking you for so that it will make sense throughout the problem. Then you're going to read the problem again and summarize important information. Okay? Then you'll turn that important information into two math sentences that you can use to create a system, and then you'll solve that system using the methods that we've already learned. Okay, here's our first example. So this says, Wendy's school is selling tickets for the upcoming Peter Pan play. On the first day of ticket sales, the school sold 5 adult tickets and 7 student tickets for a total of $97. The school took in $67 on the second day by selling 5 adult tickets and 2 student tickets. Find the price of an adult ticket and the price of a student ticket. Okay, so we read the problem. Now I want to identify what is it asking for. What are the two things that I actually need to find? And I see in the last sentence it says find the price of an adult ticket and the price of a student ticket. Okay, so I'm going to set this as my first variable, okay, the price of an adult ticket. I'm going to say let A equal this here, okay, the price of an adult ticket. Then for the student ticket, I'm going to say let S equal this, okay? Let S equal the price of a student ticket. Okay, now I'm rereading the problem to take out any important information. The first sentence is really just setting the scene. There's nothing important that I can use there. Then I see it's talking about on the first day the school sold 5 adult tickets and 7 student tickets for a total of $97. Okay, I think that's all going to be important information, so let's summarize that. So on day 1, they sold 5 adult tickets, and then 7 student tickets. And they got $97. Similarly, on day 2, they sold 5 adult tickets, 2 student tickets, and received $67 for those. Okay, so I can take that information and turn it into math sentences now. So I'm thinking, how would they get this total? What kinds of things do I need to do with these numbers in order to get a total amount of money? So I'm thinking, okay, if I sold 5 adult tickets and the tickets were, say, $10, then I got $50 from those tickets. And if I sold 5 student tickets at $7, I would get $35. So I would add them together to get my total price. So that's exactly what we're going to do to write these equations. So I'm going to take 5 times the price of an adult ticket, which again is just A. So 5 times the price of an adult ticket, plus 7 times the price of a student ticket, which is S, will give me my total money for those sales, so that's $97. Okay, for the second equation I follow the same idea, so I have 5 times the price of an adult ticket plus 2 times the price of a student ticket gives me the total for that day, which is $67. At this point, it's just a problem like yesterday's lesson, right? This is elimination, so I can subtract this whole second equation, and I get the A's canceling out. Then I have 7S minus 2S, which is just 5S. And 97 minus 67 gives me $30. Dividing by 5, I get S equals $6. And then I plug that 6 back into one of my original equations. I'll do the second one. So 5A plus 2 times $6 for S equals $67. Multiplying that, I get 12. So this is 5A plus 12 equals 67. Subtracting 12, I get 5A equals 55. So A equals $11. And you always want to go back to your variables, make sure that your answer is reasonable and makes sense. So S equals 6 means that the price of a student ticket is $6. Okay, so that's reasonable, that makes sense. Okay, then my next answer is A equals 11. So remember, A was the price of an adult ticket. So it makes sense for the price of an adult ticket to be $11. That's reasonable. So for your final answer, for these, instead of writing it as a coordinate pair like when we normally solve systems, you want to write out complete sentences because it's a word problem. So you would say the price of an adult ticket is $11, and the price of a student ticket is $6. Okay, of course, using complete sentences, I kind of shortened it to fit in that space, but you get the idea. Okay, so moving on, for the next problem is talking about the district taking field trips to the LA County Fair. So it says this year Bonita High School rented and filled 7 vans and 3 buses with 206 students. San Dimas High School rented and filled 11 vans and 9 buses with 478 students. Every van and every bus carried the same number of students. Find the number of students in each van and each bus. Okay, so this sentence is basically saying that a van is a van. So every van, if a van carries 10 students, it's always going to carry 10 students for every different van. And every bus, if one of them carries 40 students, then each and every one also carries 40 students, okay? So that's just what that sentence means. Again, we're looking for what is this question actually asking us to find. It looks like the number of students in each van and the number of students in each bus. Okay, so let's let the number of students in each van equal, or sorry, let's let V equal this. Okay, let V equal the number of students in each van, and then we'll let B equal number of students, and then this in each bus. Okay. All right, so now I'm going to look for important information. I see that Bonita High School had 7 vans and 3 buses with 206 students. So let's summarize that for Bonita High School. There's 7 vans, 3 buses, and 206 students total. Okay, then for San Dimas High School, there are 11 vans, right, 11 vans and 9 buses with 478 students. Okay, I can translate these into math equations by thinking about what my variables are. Okay, so I have V is the number of students in each van. So if I take that number, V, and I multiply it by 7, that will tell me the number of students in the 7 vans from Bonita High School. Okay, then I know if I add the number of students in the buses, right, so this is the number of students in one bus times the 3 buses. If I add those together, I should get the total number of students coming from Bonita, which is 206. Okay, similarly, I get 11V plus 9b equals 478 for San Dimas. Okay, now I want to just solve this like a regular systems problem. So I'm going to take this equation on top and multiply by a -3 and write it down here. So that gives me a -21v minus 9b equals -618. Adding these together, I get 11 plus a -21 is -10v. The b's cancel out, and I get -10v equals -140, which will tell me that v equals 14. Okay, again, I'm going to check, is that reasonable? Remember that v is the number of students in each van, so this is saying that there's 14 students in each van, which is reasonable, right? One of the big vans. Okay, then I'm going to plug v equals 14 back into one of my original equations to solve for b. So if I plug it into the first one, that gives me 7 times 14 plus 3b equals 206. Multiplying gives me 98 plus 3b equals 206. And subtracting the 98, I get 3b equals 108. So b equals 36. Okay, then I would write out in complete sentences that the number of students in each van is 14, and the number of students in each bus is 36. Okay, for the next problem, I'll let you read through that. Then we see that what it's asking for is the costs, so I'm looking for price, of 1 pack of gingerbread and of 1 pack of chocolate chip cookie dough. Okay, so for my variables on this problem, I would let C equal the price of 1 pack or 1 package of the chocolate chip, and I would let G equal the price of 1 package of gingerbread. Okay, so this is all the same. The price of 1 package of gingerbread cookie dough. Okay, my 2 equations that I would get from this information says Ashley sold 8 packages of chocolate chip, 3 packages of gingerbread, and she made 119. And Brianna sold 8 packages of cookie dough and 6 packages of gingerbread to make a total of 158. So that gives me that 8 times the price of 1 package of chocolate chip cookie dough plus 3 times the price of 1 package of gingerbread cookie dough is equal to $119. Okay, so this would be the money that Ashley gets. And then for Brianna, I'd have 8 times the price of 1 package of chocolate chip plus 6 times the price of 1 gingerbread equals $158. Okay, I would solve this by elimination, multiplying the top equation by -2. I get, it multiplies by -2. I get -16c minus 6g equals -119. Or, sorry, actually, I don't even have to do that, right? I could combine my c's right away and eliminate that variable, right? So I could just subtract this equation. Okay, so combining these, I get that the c's cancel out. I have -3g equals -39, so g equals 13. Plugging that back into one of my original equations, I get 8c plus 39 equals 119. So 8c equals 80 and c equals 10. And these are both dollar amounts, right? So looking back at my variables, this tells me that the price of 1 package of chocolate chip cookie dough is $10 and the price of 1 package of gingerbread cookie dough is $13. Okay, and then these last two show how we can use technology to solve these systems when they have more complicated numbers. So these are the two equations that I would come up with given this word problem. So this says 585 times the price of an adult, or sorry, 585 times the number of adult tickets plus 135 times the number of student tickets gives me the total amount that they would receive. Then the total number of adult tickets plus the total number of student tickets gives me the total number of tickets sold. And using Desmos, we could plug these two equations in and see that they intersect at this point. So that tells us that there was 174 adult tickets and 304 student. Okay, and in this last example, again, we get similar equations and we can graph using Desmos to find our solution. So for this problem, this was movie tickets, so 179 adult tickets were sold and 61 student tickets. Okay, and that's all for today's lesson. Thank you.